Hello, I just wanted to show you a quiz and then head into some of the topics on it. So this was the first quiz of general chemistry, and we talked about physical changes, chemical changes, intensive and extensive properties, and classifying matter. It's heterogeneous and homogeneous, pure compounds, pure elements. And then we headed into some numbers. So I asked some questions about numbers of significant figures. This is my answer key that I'm showing. And also some calculations. So this is figuring out and noticing number of significant figures when you're doing the calculations aren't always obvious in terms of what the number of significant figures will be in your answer. So we went through a few of those, but really this is what I want to talk more about in this particular video. And this has to do with unit conversions. And I want to go through some examples of this. And here's one of them. So if you're looking at metric prefix multipliers, and I asked my students to know the conversions between nanometers, nano, and micro, and milli, and centa, as well as kilo, and mega, and giga. And so in this example here, I wanted to show the thought process as you're doing these kinds of problems. So what we want to look at are if we are converting if you're asked to convert 1 gigagram to units of nanograms. So let's think about how you would do this. So you always want to think of what you're starting with. And I always start out by just writing that out. And then I can go from there and figure out, okay, what's my conversion? Where am I going? So with this, units of gigagrams. And if we're heading towards nanograms, what I do is I do it stepwise. And I think about how many grams are there in a gigagram. And I write this out, this unit conversion, as a ratio. And since gigagrams is our starting unit, and we want to convert away from that unit, then I know that I want gigagrams to be in the denominator. In any kind of ratio like this, here's the numerator, here's the denominator. And anything that's written like this is implied that it is in the numerator. And it would get multiplied by whatever's up here. It get divided by whatever's down here. So let's think again. How many grams are in a gigagram? So depending on whether you're required to memorize it or you can just look it up, you would see that there are 10 to the 9th grams in 1 gigagram. So you can make this as a ratio. These two are equal to each other. And since this is equal to this ratio essentially equals 1. So that's what allows you to multiply whatever you have here by this ratio, and it allows you to switch units. So far, we are now, because gigagrams cancels out, we are now in units of grams. And if you want, we could even do this calculation and write it out as kind of a stepwise way of getting to our final answer. 1 gigagram is 1, and I should say 1.0 gigagram is equal to 1.0 times 10 to the 9th grams. And now you can convert this to nanograms. So once again, we need to think about what we are converting from and what we are converting to. Now we have grams here. We want that to cancel out. And we want to get nanograms. So how many nanograms in a gram? Well, once again, you've either memorized it or you can look it up. And there are 10 to the 9th nanograms per gram. So now, if we go ahead, we multiply this out, grams cancel, and we now have 1.0. This isn't going to change for this kind of problem because we're only changing the 10 to the exponent here. 10 to the 18th nanograms. Okay? So let's look at a similar problem, but ever so slightly different. And so here we are going to convert and make this one a little bit different so you can see different kinds of examples. 2, 3, 4, 3, 0.5 micrometers. We're going to convert this to units of kilometers. Okay, so let's see how this works. So once again, we'll start with the value and the units that we know, that we have. So I'll rewrite this. 0.5 micrometers. Okay. And so once again, I suggest, if you're not feeling confident of how many micrometers are in a kilometer, to convert first to the base unit, in this case, meters. So, again, we make a ratio that converts micrometers to meters. We want micrometers to cancel out, so that's going to be the denominator. And if you know that conversion, again, look it up, or you can, if you have memorized it, then you would know it takes 10 to the 6th micrometers for every meter. And then, why don't I show you the way to just do these in a row so you can also see this as an example. We can convert from meters to kilometers. I didn't give myself a lot of room here, did I? Because I want to say that there are 10 to the 3rd meters in every kilometer. Then what we can do is take our initial value with our initial units. We can acknowledge that these units are going to cancel out here and here. Meters are going to cancel out as well. And that will leave us with our target unit, in this case, kilometers. And to do the calculation, we would take our initial value, divide by 10 to the 6th, and divide by 10 to the 3rd. And ultimately, when we get here, we are going to show this in scientific notation. 3, 4, 30, 0, 5 times 10 to the 5th. I'm sorry, 10 to the minus 5th. Kilometers. Okay, in this case, we should have all of our original number of significant figures. In this case, there are 6 significant figures. And those will be retained if we are just converting from one unit that is in the metric system to another, since these are exact conversions. These are exact numbers. They won't affect our significant figures in these cases. Okay? So I hope that this was helpful. I do want to give one other tip with these, because I showed one way to make these conversions, but it's helpful to show another viewpoint on this, because sometimes it depends on how you think about it, how you think about these units. So let's do this one again, okay? But 3, 4, 0.5. Okay, we are doing the same exact problem, but I'm going to show you another way to show these conversions. And that is that 1 micrometer is the same as 10 to the minus 6th meters. This ratio here means the exact same thing as this one here. Notice how this is meters divided by 10 to the 6th. That's the same as multiplying by 10 to the minus 6th. And you can also think about this in terms of micrometers being very small, and you need 1,000,000 of them, 10 to the 6th micrometers, to make up 1 meter. So for me, intuitively, this makes a lot of sense. So I usually do it this way. But it also makes perfect intuitive sense to think that, oh, a meter is larger And it's 10 to the minus 6th meter to make this small micrometer. So we can take this same idea for the next conversion, and that would be saying 10 to the minus 3 kilometer per meter. And when you carry out this calculation, your micrometers cancel out, your meters cancel out. It'll leave you with kilometers. And when you multiply this all through, you will get the exact same result. Just two different ways of thinking about it, but they do mathematically mean the same thing. So they'll both work. Alright, well, I hope that is helpful with unit conversions in the metric system. And please, as always, let me know. Let me know your chemistry questions. So I'm going to be making more that have to do with significant figures and conversions, balancing chemical equations, doing stoichiometry. A lot of those are very fundamental to chemistry and very important to know well to be able to do lots of different types of problems in chemistry. So thank you. If you have found this helpful, please like the video and subscribe and let other people know about this that you think would also benefit. I'm a chemistry professor. I've been teaching for 22 years now at universities, so I really enjoy doing this. I love ASMR, and I hope this is helpful.